Hello, hi everyone. Welcome to the store in the brand. This is your Siva sir. Today topic is light reflection and diffraction. Light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. When light incident on it, it reflect back, okay, into the same medium. So that is called reflection of light. Reflection of light. Okay. So now we can discuss. So I'm taking the plane mirror. Light reflection or diffraction, CBSE Grade-10 physics. Light reflection, reflection and refraction, refraction, refraction. Light reflection and diffraction, CBSE Grade-10 physics. Okay, so now you can observe here. When incident light rays falls on it, it reflect back. The light ray which is incidenting on the surface is called incident ray. The light ray which is reflecting back is called reflected ray. The light ray which is perpendicular to the plane surface is called normal line. Okay, so here I am taking this plane surface. So this is the incident ray, and this one is the reflected ray, and this one is the normal line. Okay, so incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. The angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Okay. So one more line is there. So that is undeviated line. Undeviated line in the sense normally in a homogeneous medium, light moves in a straight line path. In a homogeneous medium, light moves in a straight line path. Okay. So homogeneous medium means the particles present in the medium exhibit similar property. So that is called homogeneous medium. So best example, air, water and glass. Like a particular medium, if you take the properties of the medium present, okay, so the particles present in the particular medium exhibit similar properties. So that is called homogeneous medium. So light moves in a straight line path in homogeneous medium. Light moves in a straight line path in a homogeneous medium. Here you can see, so incident ray, reflected ray, normal line and undeviated line. So I'm taking this undeviated line. The angle between incident ray and normal line is called angle of incident. Angle between reflected ray and normal line is called angle of reflection. And the angle between reflected ray and deviated line is called angle of deviation. Angle of deviation. So this is the reflection of light. Reflection of light. Reflection of light. Okay. So this is the reflection of light. And coming to the laws of reflection. Laws of reflection nothing but, so incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. And angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So here you can see laws of reflection. Laws of reflection. Laws of reflection. Okay. So laws of reflections are nothing but, here you can see incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies on the same plane. And the second one, angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Okay. So that is about laws of reflection. Laws of reflection. So hi, welcome to the class. Okay. So that is about laws of reflection. Incident ray, reflected ray, normal line lies on the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So that is about laws of reflection. And coming to the reflection of light, the bouncing back of the light from the reflecting surface, or simply we can say reflection of light is known as simply reflecting of light from the reflecting surface is called reflection of light. Okay. Here coming to laws of reflection, incident ray, reflected ray, normal ray lies on the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. And coming to the one more, so here you can observe one thing. So you have to observe one thing here. Incident angle, reflected angle, and angle of deviation. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees, because linear angle is 180 degrees. So angle of incident, angle of reflection, angle of deviation. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So here from laws of reflection we can take, from laws of reflection we can take angle of incident is equal to angle of reflection, right? So from that we can write here, so angle of incidence plus angle of deviation equal to 180 degrees. So angle of deviation equal to 180 degrees minus 2 angle of incidence. Okay, so that is one. And one more thing also, angle of deviation equal to 180 minus 2 angle of reflection. So we can take like this also. Okay, so the bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Coming to laws of reflection, incident ray, reflected ray, normal line lies on the same plane. Angle of incident is equal to angle of reflection. So from the diagram you can observe angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So here from laws of reflection I am taking angle of incident, and instead of angle of reflection I am substituting angle of incidence. Then angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of reflection. Okay, so that's a point. And coming to regular reflection and irregular reflection, we'll discuss regular reflection and irregular reflection. Okay, so get ready. Regular reflection and irregular reflection. So what is meant by regular reflection and what is meant by irregular reflection, and based on this one how they will ask questions. Here till now we discussed about reflection of light and loss of reflection and angle of deviation. So they will ask about define reflection of light, one question. And coming to the next question is define loss of reflection, means write the loss of reflection. So incident ray, reflected ray, normal ray lies on the same plane. Angle of incident is equal to angle of reflection. So those two questions they will ask. And one more thing, angle of deviation, related to angle of deviation they will ask problem also related to angle of deviation, problems they will ask. So those 2 points. And one more point is that's enough. Coming to regular reflection, irregular reflection applications, where the regular reflection taking place, there irregular reflection taking place. So everything they will ask about. So we will discuss about regular reflection and irregular reflection. Regular reflection, regular reflection. So what is meant by regular reflection? Sir, what is meaning of regular reflection? So regular reflection is nothing but incident light rays are parallel, but incident light rays are parallel, then reflector light rays are also parallel to each other. Incident light rays are parallel. So angle of incident is equal to angle of reflection. Even for irregular surface also. So angle of incident is equal to angle of reflection. But if you take the normal line according to the normal line, if you consider, then it will be. Okay, so it applicable for all the surfaces. But so how it is reflecting? Okay, so it depends. That also it depends. And coming to the next one, regular reflection and Okay, so we'll discuss regular reflection and irregular reflection. So I'm taking the plane surface here. I'm taking the plane surface. So this is the plane surface. Okay, so I'm considering like incident ray. These are the incident light rays. These are the incident light rays. Okay. So reflector light rays are also I'm taking. These are the reflector light rays. Incident light rays are parallel. Then reflector light rays are also parallel to each other. Incident light rays are parallel. Then reflector light rays are also parallel to each other. So incident light rays parallel to each other. Then reflector light rays are also parallel to each other. So that reflection is called regular reflection. Coming to irregular reflection. Irregular reflection. Irregular reflection. Irregular reflection. Irregular reflection. So surface is not smooth. Surface is not smooth. It will be irregular. So I'm considering here. So here you can take. Okay. So this is the incident ray. This is also incident ray. And this is also incident ray. And so these are the incident rays. After reflection, those light rays are moving away from it. Okay, so these light rays will move in different directions. So these light rays are not parallel to each other. So these light rays are not parallel to each other. So incident light rays are parallel, then reflector light rays are also parallel to each other. But here incident light rays are parallel, but reflector light rays are not parallel to each other. So this type of reflection is called irregular reflection. Regular reflection and irregular reflection. So next one we will discuss about so object and image. Object and image. So object and image we'll discuss. So here I'm taking object. So this is the plane mirror. So this is the object I'm considering. Light rays are coming from this object. Okay. After reflection, this is one light ray I'm taking. This is one light ray. So that light rays are reflecting. After reflection, they are moving away from it. Okay. So here you can observe. So these are the dotted lines. Okay, so if you are extending here, this is the virtual image. So this is the real object and virtual image. Sir, why it is a virtual image? So here you can observe from the point light rays are coming, from the point light rays are coming. Okay, so here I am taking, so from this incident light rays are coming, this is a real object. After reflection, light rays are moving away from it. After reflection, light rays are moving away from it. So if you are extending these reflector light rays, so extended reflector light rays are meeting at one point. Extended reflector light rays are meeting at one point. Their image is forming. That is a virtual image. That is a virtual image. Coming to the one more. So here I am considering like this. So this is a plane mirror. So like this is one object, and this, sorry, light rays are coming from infinity. After reflection, so here you can observe. Okay, so if you are extending these light rays, so extended light rays are meeting at one point. Extended incident light rays. Here we are extending. Okay, so we are extending the incident light rays. Extended. So this is the real image and virtual object. So here you can observe one thing. From here, light rays are coming. Incident light rays are coming after reflection. So reflector light rays, extended reflector light rays are meeting at one point. Their virtual image is forming. Here you can observe. So these are the incident light rays. After reflection, those light rays are meeting at one point. That is a real image. Okay, so after reflection, reflector light rays are meeting directly. Reflector light rays are meeting directly. That's why it is called real image. So if you are extending the incident light rays, extended incident light rays are meeting at one point. That is a virtual object. That is a virtual object. Okay. So this is about object and image. So you can observe here. So I'm taking like this. Okay. Object and image. So object is real, image is virtual. Object is virtual, image is real. So you can observe here by observing these two diagrams. By observing these two diagrams, we can conclude that object is real, image is virtual. Object is virtual, image is real. Vice versa. Object is real, image is virtual. Object is virtual, image is real. So this is about object and image. And the next one, nature of the image formed by the plane mirror. So we'll discuss about nature of the image formed by the plane mirror. Okay. So next one, nature of the image. So here you can observe, I am taking here, this is the plane mirror. This is a plane mirror. So I am taking the object here. This is the object AB, AB. Okay. So AB, right? So how many light rays are required to form the image of the object? How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Okay, so I'm taking one light ray here. This is one light ray. So after reflection, and here one more light ray I'm taking like this. So those light rays are moving away from it. And here also you can take. These are the reflector light rays. Okay, so here you can observe. So here I'm taking. So these are the extended reflector light rays. Extended reflector light rays are meeting at one point. Okay, so here you can observe these are their image is forming. This is a virtual image. So A dash and B dash, A dash and B dash. Okay, so here you can observe one thing. So in the previous case, I explained object is real, image is virtual. Object is real, image is virtual. Point number one. Object is real, image is virtual. Object is virtual if condition is very important. If object is real, image is virtual. If object is virtual, image is real. So second point is object distance. The distance between object to image, object to mirror. The distance between object. So this is the object and this is the mirror. The distance between object to mirror is called object distance, and the distance between mirror to image is called image distance. Once again, the distance between object to mirror is called object distance. The distance between mirror to image is called image distance, because this is the plane mirror. So one side is reflecting surface, another side is coated, silver coated. Okay, so image will form in so object. If your object is placed, image will form. What type of image will form in the plane mirror? Virtual, erect, and same size. Virtual, erect, and same type of image will form. Okay, done. So here you can observe here. Object is real. If object is real, image is virtual. If object is virtual, image is real. So like that, vice versa. I am taking object distance is equal to image distance. Object distance is equal to image distance, and also height of the object is equal to height of the image. Height of the object is equal to height of the image, and also magnification of the plane mirror is +1. Magnification of the plane mirror is +1. So m equal to +1. Magnification of the plane mirror is +1. So here we can take. So plane mirror shows lateral inversion. So plane mirror shows lateral inversion. Lateral inversion. Lateral inversion. So what is meaning of lateral inversion? Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. So the phenomena of converting of right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. Okay, so this mirror image is called lateral inversion. This mirror image is called lateral inversion. I hope it is very clear, right? So this mirror image is called lateral inversion. Once again, object is real, image is virtual. Object is real, image is virtual. If object is virtual, image is real. Object distance, the distance between object to mirror is called object distance. The distance between mirror to image is called image distance. Height of the object is equal to height of the image. Height of the object is equal to height of the image, and size also we can take. So not only height of the object, or size of the object is equal to size of the image, and magnification of the image is magnification of the plane mirror. Magnification of the plane mirror is +1. Magnification of the plane mirror is +1, and also shows lateral inversion. The lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. This mirror image is called lateral inversion. So I hope it is very clear. So this is about plane mirror. Next. Next, spherical mirrors. Spherical mirrors. Okay. Spherical mirror. So we can observe here the mirror which in the form of curved shape. The mirror which in the form of curved shape is called spherical mirror. Okay, so here small portion I am taking. The small portion is called curvature. The small portion is called curvature. That is called spherical mirror, concave mirror. Concave mirror. So here I am taking concave mirror like this. So concave mirror is also known as converging mirror, concave mirror, concave mirror, concave mirror. Concave mirror is also known as converging mirror, converging mirror. Concave mirror is also known as converging mirror. And a convex mirror is called diverging mirror. So concave mirror is also known as converging mirror, whereas convex mirror is also known as diverging mirror. So I prefer textbook CBSE grade 10 physics. So science. Okay. So read textbook thoroughly. Reference books you can prepare. First preference you can give to textbook. Okay. Done. Come to the point. Concave mirror is also known as converging mirror, whereas convex mirror is also known as diverging mirror. Next one we will discuss about ray rules. Ray rules. So if you want, you'll do one thing, Vaibhav. So you can check my notes. I have written notes. Already it is there in the Telegram link. You can check once. So if it is useful, then accordingly you can follow the remaining book. Check once. Check the notes. Whether it will be helpful, whether it is useful, whether it is relevant or not, you can check once. So according to the CBSE grade 10 physics, so topics wise, chapter wise, I have written. So everything related to in detailed concept. So I only written handwritten notes. You can check once your purely notebook for 4 chapters, including electricity problems and 100 definitions from 4 chapters. So if you want, you can check. I have given link in the description below. Check once in the Telegram channel. So 4 chapters notes is available. You can check. So coming to the ray rules of concave mirror. Ray rules of concave mirror. Concave mirror. Ray rules of concave mirror. So now I am taking this is a concave mirror. So before that, so I'll discuss about terms related to spherical mirror. Terms related to spherical mirror. So before discussing ray rules, so we'll discuss about terms related to spherical mirror. Terms related to spherical mirror. Are terms used in spherical mirror. Spherical mirror. Spherical mirror. Okay, terms related to spherical mirror. Terms in spherical mirror. So now we'll discuss. Okay, so what are the terms we are using in spherical mirror? Just check once. So I'm taking the concave mirror here. Concave mirror. So actually, this is the part of this sphere. This is a part of this sphere. Okay, so here I'm taking this is the center of the imaginary sphere. Center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part. And midpoint of the mirror is called pole. Midpoint of the mirror is called pole. The distance between center of curvature to pole is called radius of curvature. The distance between center of curvature to pole is called radius of curvature. Okay, and so after reflection, all light at one point. So I'm taking all light rays here. These are the light rays. After reflection, all light rays are meeting at one point on the principal axis. Is called focus. Okay, so the distance between center curvature to pole is called radius of curvature. After reflection, all light rays are meeting at one point on the principal axis called focus. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. And the width of the mirror is called aperture. This is the width of the mirror is called aperture. Okay, first one is center of curvature. Second one is pole. Third one is radius of curvature, and fourth one is focus. Fifth one is focal length, and the sixth one is so the line joining of or the line passing through the center of curvature and pole. The line passing through center of curvature and pole. The line passing through center of curvature and pole is called principal axis. Teach class 9. Yeah, so I'll teach motion, gravitation, sound chapter, laws of motion. Okay, sure, I'll discuss. Definitely. Okay, done. So radius of curvature. So the line joining of center curvature and pole is called principal axis. Principal axis. Principal axis. Principal axis. Okay. The line joining of center curvature and pole is called principal axis. Once again, So, and the width of the mirror is called aperture. So, last one is, seventh one is aperture. Aperture. And the width of the mirror is called aperture. So, once again, so check here what are the things are there. Center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part. So midpoint of the mirror is called pole. Midpoint of the mirror is called pole. And the distance between center curvature and pole is called radius of curvature. And after reflection, all light rays are meeting at one point. Which date in the sense? Okay, you just follow. Just check once in the community post. Community post. I will update. I'll update when I'm going to start. So actually, I'm planning to do 11th and 12th also. 11th and 12th, like how I'm teaching for grade 10, for grade 11 and 12 also, like chapters I'm going to start. Already started, but still with more, okay, with more intensity, with more explanation, I'm going to start. And for grade 12 also, like current electricity chapter I started. Still I'm going to continue the remaining chapter, electrostatics, and so on. So to go on. Ninth class, I'll start. Now you can check in the community post. I'll post, definitely I'll post. So when I'm going to start, I'll take one class, definitely I'll take one class. So I'll schedule the class. So this chapter, this time, this chapter, this time I'll post. Maximum today or tomorrow I will make a schedule and post. Okay, in the community post, check the community post. So today at the end of the day or tomorrow by end of the day you can check. So you'll get to know the definitely you'll get to know when I'm going to teach that particular chapter. Then you can join to the class, live class. Okay, so I hope it is very clear. And now, so center of curvature, center of the imaginary sphere in which mirror is a part, and pole is the midpoint of the mirror. So the distance between center of curvature and pole is called radius of curvature. So after reflection, all light rays will meet at one point is called principal focus or focus. So the distance between focus to pole is called focal length. And the line joining of center curvature and pole is called line joining of center curvature and pole is called principal axis. And width of the mirror is called aperture. Width of the mirror is called aperture. Okay, so next, now we will discuss about ray rules. We will discuss about ray rules. Actually, without discussing these points, we can't discuss ray rules because these are all interlinked topics. These are all related topics, because so every time when you are drawing the ray rules and image formations, so compulsory we need to learn or we need to recall these points. So the pole, focus, center curvature. Okay, so you have to recall the definitions, not only mentioning the points, you have to recall the definitions also. So that is very, very important. Whenever you are mentioning particular point, so if I am drawing ray rules, if I am mentioning center curvature, immediately you should get that. Okay, you should recall the definition. Okay, center of the imaginary sphere in which mirror is a part. So if I mention focus, so after reflection, all light rays will meet at one point on the principal axis is called focus. So principal axis, the line joining of center curvature and pole is called principal axis. Like that, you have to recall all the points. You have to recall all the points every time when you are drawing the, when you are mentioning the terms related to spherical mirror. Or nomenclature also we can take. Now ray rules of spherical mirrors. Ray rules of spherical mirrors. Spherical mirrors. Spherical mirrors. Ray rules of spherical mirrors. Okay, so point number one. See here, I am saying, right, so just now I said regarding this point. So this is the pole, focus and center curvature, pole, focus and center curvature. So light ray is coming from infinity. After reflection, it passes through focus. Light ray is coming from infinity. After reflection, passes through focus. So this is the first one. And coming to the second one, light ray is passing through focus. After reflection, it moves towards infinity. So pole, focus and center of curvature, light ray is passing through focus. So after reflection it moves towards infinity. So this is second one, first one and second one. And coming to the third one, so here I am taking here, so pole, focus and center of curvature, pole, focus and center of curvature. So if the light ray is passing through center of curvature, after reflection it retraces its original path. And coming to the fourth one, so if the light ray is incidenting at the pole, it reflects back. The light ray is incidenting at the pole, so it reflects back. So here I am considering like this. So this is the pole, focus, center of curvature, light ray is incidenting at the pole. So after reflection, so it moves in the same into the same medium. So this is about concave mirror. So 1, 2, 3, 4. So 4 rules, 4 ray rules. And coming to the, this is a concave mirror. Concave mirror is also known as converging mirror, right? And coming to the convex mirror. Convex mirror. So pole, focus, center of curvature, light ray is coming from infinity after reflection. So actually it is a diverging mirror. So whenever light ray is incident, it will diverges. And coming to the second one, so pole, focus, center of curvature, pole, focus and center of curvature. So light ray is coming from infinity. After reflection, it moves towards infinity. And coming to the third one, so this is the pole, focus, center of curvature, light ray is passing through center of curvature, right? Light ray is passing through center of curvature. After reflection, it retraces its original path. And coming to the fourth one, so this is the pole, focus, center of curvature, light ray is incidenting, so it reflects back. Light ray is incident at the pole, it reflects back. Okay, so I hope it is very clear. So this is about ray rules of concave mirror and convex mirror. Concave mirror and convex mirror. So light ray is coming from infinity, after reflection passes through focus. Light ray is passing through focus, after reflection moves towards infinity. Light ray is passing through center of curvature, it retraces its original path. Light ray is incident at the pole, it reflects back. So light ray is coming from infinity, after reflection moves. Okay, so passes through focus. Light ray is passing through focus, after reflection moves towards infinity. Light ray is passing through center of curvature, it retraces its original path. Light ray is incident at the pole, it reflects back. So these are the ray rules of concave mirror and convex mirror. So now we will discuss about image formations of concave mirror and convex mirror. Image formation. So let's discuss about image formation. So image formations of concave mirror and convex mirror. So very important, especially image formations. And here, sir, not only image formations, so related to problems also. These image formations are very important. So in the problems they will ask, okay, object is placed between center of curvature and focus, where image will form. What is the nature of the image? So object distance they will give, focal length they will give, and they will ask to find out image distance. So like that questions they will ask. So for that, after calculation, whether you are getting, whether whatever you got that is correct or not, how to check? You have to know the diagram. Okay, so you have to know the image formations. So if you draw the image formation, then you will get to know it is virtual image or erect image or real and inverted. So what type of image you are getting and where it is coming. So if you know the focal length, automatically you will get the center of curvature. So by that, after knowing object distance, we'll get to know immediately where image will form. Okay, so what is image distance? Okay, so by using mirror formula, so anyway, mirror formula I'll explain just. Okay, so image formations are very, very important. Okay, so image formation by concave mirror, image formation by convex mirror, so very, very important. So you should understand. Okay, just we'll discuss. So coming to the next one. So image formations of concave mirror. So I'm taking the concave mirror here. So this is the pole and focus, center of curvature, pole, focus and center of curvature. So and coming to the next one now. Actually, we have to do some questions related to light reflection. So refraction topic also there. So based on refraction topic also we have to discuss questions. So very, very important questions where they will concentrate. Okay, so which concept is very important and expected questions from the concept. What type of, what are those concepts? First concept is laws of reflection. Second concept is nature of the image formed by the plane mirror. Third concept is, after that, terms related to spherical mirror. Very, very important, definitely one question. And the laws of reflection definition. And one more question, plane mirror. Nature of the image formed by the plane mirror. Based on that one they will ask. After that, one more, image formations. Now whatever we are discussing, based on image formations also they will ask. So after this one, sign conventions. Sign conventions are very, very, very important. Very, very important. So you have to read at any cost. So that much important it is. You have to read. You have to learn it. That much important is. So I'll discuss all those points. Just let's start. So I'm taking here object is at infinity. Object is at infinity. So how many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. So one light ray I'm taking like this, another light ray I'm taking like this. After reflection, those light rays are meeting here. So object is at infinity, image is forming at focus, nature of the image is real and inverted and highly diminished. Highly diminished. So there is the first one. Coming to the second one. So this is the pole, focus and center of curvature. Object is placed beyond center of curvature. So I place the object here. How many light rays are required to form the image of the object? Minimum 2 light rays are required. So one light ray I am taking like this, another light ray I am taking like here. Okay, so here you can observe. So image will form between C and F. Image will form between C and F. So image will be here. Okay, object is placed beyond C. Object is placed beyond C. Image is forming between C and F. Nature of the image is real and inverted. And size of the image is diminished. So we can't say highly diminished. So just we have to mention diminished. Diminished image is forming. Diminished image. Diminished image. Okay, so coming to the third one. So here I am taking here. So pole, focus and center of curvature. Object is placed at C. Object is placed at C. Where image will form? At C itself. If object is placed, image also will form at C itself. So image also will form at C. Nature of the image is real and inverted. So image will form at C. So one light I am taking like this. So here one more light I am taking here. Okay, object is at C, image also with C. Nature of the image is real and inverted and size of the image is so same size. Nature of the image is same size. Okay, so size of the image, nature of the image is real and inverted, same size. So size of the image is same size, nature of the image is real and inverted. Okay, so there is lot of difference. So nature means real and inverted, size means same size or diminished image or enlarged image, highly enlarged. So like this it will come. So nature means real inverted, virtual erect, like that. Understood? Okay, done. Coming to the fourth one. So here I am taking this is a pole, focus, center of curvature, pole focus and center of curvature. Object is placed between C and F. Object is placed between C and F. One light ray I am taking like this, it passes through it. Another light ray is incidenting at the pole, it reflects back. So here the image is forming here between the, so if the object is placed between C and F, image is forming here beyond center of curvature. Okay, object is placed between C and F, image is forming beyond center of curvature, beyond C. Nature of the image is real and inverted, size of the image is highly enlarged. Oh, enlarged, that's enough. Highly enlarged at focus, enlarged, enlarged. Okay, so compared to the object, image size is increased. Compared to the object, image size is increased, then that is enlarged image. Coming to the fifth one. So object is placed at F, image is forming at infinity, nature of the image is real and inverted, and size of the image is highly enlarged. And coming to the sixth one is very important. Sixth one is very important. So you can observe here. Pole, focus, center of curvature, pole focus and center of curvature. Object is placed between F and P. One light ray I am taking like this, it passes through focus. Another light ray is passing through focus after reflection. So we are extending this. Okay, so here object and image, object and image, object and image. Okay, so very important this case. Object is placed between F and P, image is forming behind the mirror. Nature of the image is virtual, erect and enlarged. Nature of the image is virtual, erect and enlarged. So very important case. So make sure that you are practicing this one. Okay, that's enough. Next one. So convex mirror will discuss. Convex mirror is a diverging mirror. Convex mirror, only two cases are there. So pole focus and center, pole focus and center of curvature. So one light ray I'm taking like this, another light ray I'm taking like this. After reflection, those are moving away. If you are extending, so those light rays will meet. Okay, extended light rays will meet at focus. Object is at infinity, image is forming at focus. Nature of the image is virtual, erect, and highly diminished. Highly diminished because point size image is forming at focus. Point size image is forming at focus. And coming to the second one, so coming to the second one here. So pole, focus, and center of curvature. Object is placed here. One light ray I am taking like this, another light ray. So here. The image will form between P and F. The image will form between P and F. Object is placed between P and infinity. Image is forming between P and F. Nature of the image is virtual, erect, and diminished. Virtual, erect, and diminished. Compared to the object, image size is decreased. Compared to the object, image size is decreased. So this is about virtual, erect, and diminished image. Next one, we are going to discuss about sign conventions. Sign conventions. Sign conventions. Sign conventions. So now we are going to discuss about sign conventions. So now you can observe here. Sign conventions. Sign conventions. Sign conventions. Sign conventions. Sign conventions. So pole, focus, center of curvature. So in the direction of incident rays are positive, opposite incident rays negative. Height of the image and height of the object positive, and the height of the image and height of the image is negative. Okay, so like a coordinate axis. So you know the coordinate axis: positive x-axis, positive y-axis. Okay, positive x-axis, negative x-axis, positive y-axis, negative y-axis. Positive x-axis, positive y-axis, positive y-axis, negative x-axis, negative y-axis. Okay, so same thing here also you can take. All measurements we are taking from the pole in the direction of incident rays all are positive. All distances like image distance, object distance, focal length, and radius of curvature. Opposite incident rays all are negative. Above the principal axis positive, below the principal axis negative. Okay, same thing. I'll sing as a song. So just listen. New Cartesian sign convention. New Cartesian sign convention. All a distance measure from the pole. Distance are positive along the instant rays. Distance are negative opposite to instant rays. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. So like that, so you can take. Okay, so new Cartesian means normal sign conventions only. All distance are positive along the incident rays. All distance are negative opposite to incident rays. Above the principal axis positive, below the principal axis negative. So this is about new Cartesian sign conventions. And coming to the mirror formula, 1 by f equal to 1 by v plus 1 by u. And magnification is height of the image by height of the object, that is nothing but minus v by u, right? So this is about light reflection chapter. Actually light refraction also there, so refraction topic also there. So just now I discussed about light reflection, light refraction also we'll discuss. So if you like the content, if you like the explanation, if you like the channel, do like, share and subscribe to Student in the Brand. So this is our Siva sir. So go and check my videos, go and check the content. So if you like the content, you can share to your friends, ask your friends to join to the live class. So grade 10 already started going on. Grade 11 also started, grade 12 also started, and grade 9. So I'll start. Okay. So on your demand, definitely I'm going to start. So thank you so much for joining and attending and listening my class. This is our Shiva sir from Student Brand. Thank you so much for joining and attending and listening my class and giving an opportunity to teach the class. The class. Okay. So thank you so much. So keep attending, keep uh, so listen the class. So definitely you can prepare. We'll see you in the class. So thank you.